In about a month, scientists could be one step closer to learning about the origins of our planet from an asteroid that has a chance of destroying Earth. Yeah, you heard me. NASA's OSIRIS-REx spacecraft will travel to the asteroid known as Bennu to harvest a sample of surface material. So let's dig into this. Joining us from Philadelphia is Derrick Pitts. He is the chief astronomer at the Franklin Institute. Derrick, good to see you.
Thank you, Vlad. Great to be here.
Yeah, so this is sort of scary, but also sort of interesting. So explain to us what this mission is all about.
Well, what scientists hope to accomplish with this mission is to learn more about the early history of the solar system. This particular asteroid, Bennu, is one of a very small number of asteroids that satisfy a list of criteria that make it excellent to explore. And it has to do with things like what kind of organic materials it has, what kind of orbit it's in, how well preserved its original surface is. And it's thought that this particular one has a very well preserved original surface, and in that way it can help us understand what the early conditions of the solar system were like. And so this is a great way for us to learn that. So that's why this is such a great asteroid for us to take a look at.
All right, so we now know why the asteroid Bennu was chosen, but how long will it actually be before it returns to Earth with the samples so that scientists can study it?
Yeah, that's a really interesting question. You know, the plan is to launch the satellite in September next month, and it will take it 2 years to actually get to the asteroid where it can do this work that it has to do. Now, remarkably enough, even though they'll orbit the asteroid for a bit, they'll only touch down on the surface of the asteroid for 5 seconds. 5 seconds, Vlad, wow, to be able to capture some of the dust of the surface and bring that back to Earth. But the mission won't get back to Earth until 2023. So it seems like a very long mission. It is sort of roundabout because of how they have to engineer the orbital path to get there and get back safely. But at least we'll have a real sample of a very early asteroid from the early history of the solar system.
And we're just showing really cool graphics there and video as put out by NASA that just sort of shows how it's going to do that. And you can see that it can get and make that happen within 5 seconds. But Derrick, we also mentioned that Bennu could collide with Earth sometime in the 22nd century. How likely is that?
Well, there is a slightly dark side to this, Vlad. And the slightly dark side is that right now, the way it stands, is that there's a 1 in 2,700 chance that this asteroid could have, let's say, a close encounter with planet Earth. Now, 1 in 2,700 is not very high odds. As it turns out, this asteroid is really good for us to examine because of the type of orbit it has. That type of orbit brings it close to the Earth on a regular basis, and so that means it's easier for us to get to. But then there's the other problem of, do we have to be concerned that it might actually strike us at some point in our future? Well, the date that we have to think about now is 2175. If anything were to happen, it won't happen until 2175, but even then or afterwards, it's still a 1 in 2,700 chance that it will actually strike Earth. Now, the other part of the research that gets done here, Vlad, is not only to figure out what's going on with the surface and the composition, but also to understand better what the orbit of this asteroid is like and to determine what kind of factors are actually shaping its orbit as it makes its way around the sun. One of the things we might hope to learn is that there are other dynamics besides gravity, like thermal dynamics, that might help to alter its orbital path as it's going through space, so that it might not come anywhere close to Earth in 160 years.
All right, so let me just geek out and nerd out with you for just a moment. Just in case that 1 in 2,700 chance comes to fruition. There was a scientific study put out by the Journal of Physics called "Could Bruce Willis Save the Earth?" And of course, I'm talking about Armageddon, right, where they decide to send a nuclear device into this asteroid that's coming towards Earth. Michael Bay, you know, directed movie, lots of explosions, lots of corniness. There's actually a scientific study that came out, Journal of Physics, so it's not completely geeky. And it's interesting, Derrick, they said that perhaps a nuclear device could at least destroy an asteroid. But I'm reading here from the actual scientific study that they would have to have a really, really big nuclear device. The bomb in question that they used as a model for this was one of the biggest ever detonated. It was a Russian bomb called the Big Ivan, which is a great name. It had an overall yield of 50 megatons. For something like this, you would need 8 times more what 50 megatons is like, and I can't even imagine what that is.
Yeah, well, think of it like this, Vlad. A few years ago, there was an asteroid that came very, very far down into the Earth's atmosphere over a city in central Russia called Chelyabinsk. And the Bennu asteroid is 4,000 to 5,000 times more massive than that asteroid was. Now, that little asteroid that came down so close over that central Russian city caused a lot of widespread damage, not tremendous damage, but it certainly signified that if something were to actually hit the surface, it could be very damaging. So this object we're looking at is something that would cause a tremendous amount of damage across a very wide region of the planet. So we want to make sure that it's not going to be coming in this direction. Now, as to what to do, I say send Bruce Willis. Send Bruce Willis for sure, but don't send a nuclear warhead. There are other ways to do that. In fact, if you try to blow it up, what it really does is it creates a field of smaller objects that are all still on the same velocity heading towards us. So now we have damage spread over a much wider area. A better thing to do is to try to figure out how to gently push it off course over a period of time, which is why the research about what these objects are and where they are is so important, so that we have time early enough to do something about it before we get to a critical juncture point.
All right, Derrick Pitts, thank you very, very much. In the commentary for the movie, Ben Affleck said he could never understand why they didn't train astronauts to be drillers as opposed to having drillers trained to be astronauts. But that's a discussion for another day. Derrick Pitts, as always,
We'll do
thank
that.
you.
Thank you, Vlad.